Hello everyone, welcome to the online lecture series of Vehicle Testing and Homologation. I am Milan Trivedi, professor at LJ Institute of Engineering and Technology. This is our fifth lecture in online lecture series, and we were actually discussing about the second chapter of Vehicle Testing and Homologation, that is engine, fuel system and emission testing. Up till now, in the last lecture, we had already covered about the fuel measurement method as well as the speed measurement techniques. In today's presentation, we will start with the air consumption measurement. Now, talking about the air consumption measurement, it is one of the complex process because it is very easy to measure the solid constituent or the liquid particles, but whenever it comes to the measurement of air, it becomes a critical process. So for that reason, we require a special kind of apparatus in order to measure the amount of air which is consumed by an engine. Whether it is a petrol engine or diesel engine, we attach this kind of apparatus in order to measure the amount of air consumed by the engine. Okay, so let us start with the measurement technique. The instrument or the technique which we are using to measure the air consumption is airbox method. Let us first of all understand the construction part of the airbox, then we will understand the working of it. As shown in the figure, we are having one surge tank. This surge tank is actually storing the air. From this surge tank, air will pass to the engine. This surge tank is having orifice at one of its end through which fresh air can be taken inside. This surge tank is also connected with thermometer which can indicate the temperature of the air. At the bottom part you see there is one YouTube manometer which is used to measure the pressure of the air. So in total we are having two different apparatus, thermometer and manometer attached to the surge tank. So that is its construction part. Now let us understand the working of it. Now when we start the engine, from the orifice, fresh air will be taken inside the surge tank and it will be passed to the engine. But the temperature and the pressure of that air is being noted with the help of thermometer and manometer. But our main reason to have this process is to find out the mass flow rate, right? So how we are achieving this mass flow rate, that we are going to see in detail now. See, we can directly get that volume flow rate with the help of this empirical relation, that is coefficient of discharge multiplied with the area of orifice multiplied with under root 2gh. Okay, so coefficient of discharge is fixed. Area of orifice you can find out with the help of knowing the area of orifice. Suppose it is a circular in section, then obviously you can find out by pi by 4 d square. Suppose it is a rectangular orifice, then you can directly find out by multiplying length into width. So that is not a complex thing. Under root 2 into acceleration due to gravity, that is 9.81 is fixed. We are multiplying that with delta H. This we actually need to understand. This delta H is common for water, that if it is for water then we can directly get from this manometer, but delta H value of air we need to find out. How to find the delta H air? See, here also it is written that head of water is required to be converted into air head. In order to convert that water head into air head, we are having this relation that H is equal to delta H by 100 into mass of water divided by mass of air. But how to find out this mass of air? For mass of air, we are using this formula PV is equal to MA into R into T. Volume of tank, we are fixing it as 1 meter cube. So obviously that value will be 1. So MA comes out to be equal to P by RT. Value of R, that is 287 joule per kg Kelvin, that is again constant. Two parameters remaining are pressure and temperature. The pressure of air will be measured with the help of manometer, and the temperature will be measured with the help of thermometer. So from this you will be having a value of MA. You put that value in this and you will get the value of head of air. Put that in this formula, you will get the flow rate of the air. So in this way we can find out the amount of air which is utilized by the engine. Okay. The first go, it seems to be complicated process, but actually if you see at the minute level, then it is totally dependent on formula basis. Okay. So this is how we find out the air consumption. Let us move further. Our next topic is to measure the exhaust gas emissions, right? Amount of constituents present in the exhaust gas. Let us see the different techniques to measure the exhaust gas, in which the first and the very most important technique is the non-dispersive type infrared analyzer. This analyzer is actually measuring the amount of different gases present in the exhaust gas. Say for example, the constituent of carbon dioxide, carbon monoxide, NOx, that all levels can be found out with the help of this kind of non-dispersive infrared analyzer. Let us first of all understand the work construction part, then we will understand the working. As seen in the figure, we are having one light source from where the infrared light is passed. That light is passed on one parabolic mirror or reflector. From parabolic reflector, it will be passing through two different containers. One is having sample gas, another is having a reference gas. This gas temperature is measured with the help of thermopile. Right? This is simple construction of it. Now let me elaborate the working part of non-dispersive infrared analyzer. Our main experiment will start from this light source. Light source is kept at focus point of the parabolic curve. Now what will happen when you keep any light source at the focus point of parabola? Obviously the light will transmit on the parabolic surface, then it will be having one parallel rays, horizontal and all parallel rays, right? Just to make all the rays parallel, we are using this parabolic mirror and we are keeping light source at the focus lamp. We are using this parabolic concept in number of ways. Just for an example, in our headlamp of car or any two-wheelers, we are using this kind of reflector, parabolic reflector, and we are keeping light source at the focus point itself, so that rays become parallel. Okay, so that concept only we are using over here. Now, what is actually happening to the rays? These rays are allowed to pass through two different containers. Upper one is having a sample gas. Sample gas means our exhaust gas. That gas in which we actually need to measure the different gas constituent. Carbon dioxide level, NOx level, carbon monoxide level, that container. Below to that, we are having a reference gas container in which we are keeping the inert gas such as nitrogen. Why we are keeping this inert gas? Because it is a kind of non-reactive gas. It won't react with the presence of light, right? So we are keeping inert gas in the reference gas section. Now the gas which is coming out from this particular containers, their temperature has been recorded with the help of this thermopile, right? Now let us understand the in-between working principle. Whenever the infrared light enters the container, the gas, exhaust gas, in which, say for example, there is carbon dioxide, then carbon dioxide will try to absorb that particular infrared light. And on absorbing that infrared light, the temperature of gas molecules will increase, right? And that increase in temperature has been recorded by the thermopile. So this will indicate the amount of presence of that particular carbon dioxide in the exhaust gas. Now, why we are keeping this reference gas? This reference gas is for the comparison. Whenever the infrared light enters this inert gas region, inert gas doesn't react anything or not at all with the infrared light. So the temperature of gas won't raise. So this will indicate certain reading. We need to compare these two readings. From that we will get the value that this much amount of carbon dioxide is present in this. We are actually doing certain formulation on that, and from which we come to the result that this number of constituent of gas might have present. Okay, so this is about the working. But yes, the question will arise that how to know that only carbon dioxide has absorbed the uh, infrared light. What if NOx has absorbed the light? But every gas is absorbing the light of different wave number. Say for example, carbon dioxide is absorbing the infrared light maximum when there is a wave number in between this range, right? And if you take the ethane, for example, then it is absorbing the infrared light of wave number 3000. So you need to set an infrared light of different wave numbers in order to get the better result. Okay. So this is all about the NDIR, non-dispersive infrared analyzer. It is the most commonly used equipment. Now let us understand the second measurement technique of exhaust gas. Uh, this flame ionization detector, before even we start this topic, let me just brief you that this analyzer is only used in order to measure the amount of hydrocarbon present in the exhaust gas. We cannot measure all the gas constituent. We just can measure the amount of hydrocarbon present. Now let us understand the construction part. First of all, we are having one container. Container is actually having one provision to have a heat generation. But we know in order to generate the heat, we actually require three different things. First is the supply of air, second is fuel, and third, igniter, right? So for this lighting the flame, we are supplying air. For fuel, we are supplying hydrogen. There is one specific reason to supply the hydrogen. Along with that, we are having one igniter. Igniter will ignite that air hydrogen flame, so flame would be generated. Now, flame part is connected to the positive portion, we are calling it as anode, and upper part of the flame is having one cathode connection, that is a negatively charged electrons. Now, what will happen when we keep exhaust gas inside this container? Then the hydrocarbon present in the exhaust gas will have one effect due to the air hydrogen flame. Due to that air hydrogen flame, number of ions will be produced. Now that ions will be attracted towards the cathode, that will try to be reach to this cathode region, right? The more the number of hydrocarbon, more the number of ions will be there. More number of ions will be accumulated at this cathode part, and that will generate certain supply, right? So as it will complete up with the cycle, so the amount of ions produced is being noted, which is actually giving you the indication of the amount of presence of hydrocarbon, right? It seems to be a bit complicated process, and almost some of the chemistry is also involved, as it is dealing with the generation of the ions, right? Apart from that, the limitation of this is we just measure the hydrocarbon only, because hydrocarbon only is having tendency to generate the ion in the presence of hydrogen flame, right? All other gases are either non-reactive or they are not producing the ions. Here the generation of ions is important. How much amount of ions is getting generated, that is actually giving you the value of the presence of hydrocarbon molecule, right? So at a number of places, just for only one gases, this whole apparatus becomes bit costful, right? So we are not using this in order to measure all the different gases. Fine. So that's all about the exhaust gas measurement technique. We are keeping just up to this. Thanks for watching.